Welcome to Sundar's lecture. This is lecture number 31, and in this lecture we are going to see realization of other flip-flops using D flip-flop. So what we are going to do now, we are having D flip-flop and we are going to build SR flip-flop, T flip-flop and then JK flip-flop using D flip-flop, right? The operations of those flip-flop can be performed with the D flip-flop. So I have taken the excitation table of the D flip-flop here. So what are the flip-flops we are going to convert now? So we are going to convert D flip-flop to, that means we are going to use the D flip-flop as SR flip-flop. That is the first one we are going to see, and the second one will be we are going to use D flip-flop as T flip-flop. That is the second one we are going to see, and the third one we are going to use D flip-flop to JK flip-flop. See, these are all the three things we are going to see in this lecture. If time permits, we can also see the conversion of other flip-flops using T flip-flop, right? So we will see one by one. So what are all the topics we have seen in the previous classes? So the topics we have taken in the previous classes. That means we have just converted the SR flip-flop to the other flip-flops. That means SR flip-flop to JK, SR flip-flop to D, then SR flip-flop to T flip-flop. Everything we have seen in the previous class. And what are all the procedures we have seen? See, first we need to take the truth table of the flip-flop which we are going to perform. That means which we are going to convert, right? So on the next one, excitation table of the flip-flop whichever we are having with us, and then we are going to draw the conversion table. That is the third step, and the fourth step is the conversion table, and the fifth step is we are going to derive the expressions for, here we have derived it for SR, but now we are going to derive it for D flip-flop. That means only one input with the flip-flop we are having, so we are going to derive one equation only, and then we are going to draw the logic diagram. So these are all the procedures we have seen in the previous class, and we will try to do the same thing in this class also, right? So these are all the contents we are going to see now. So the first step that is what we have taken. That means the first one we will take D flip-flop to SR flip-flop. That is the conversion we are going to do now. So for that we need the first point we need excitation table. So we have the excitation table, that means excitation table of the D flip-flop that we have with us now. And what is the second thing we need? Truth table of which of the flip-flop you are going to convert. That truth table you need here, so that is SR flip-flop, and then the C, which is the conversion table, right? So first we see these three steps. Conversion table, I will draw the conversion table anyhow. So we will take this one first separately, one by one, and then I will show you the conversion table. Right, now you can see here, I have just taken the excitation table of the D flip-flop here, and then truth table of the SR flip-flop here, and the conversion table I have just drawn the conversion table, and I have already told you in the previous class, the conversion table we have to take the truth table as it is same, and here what you need to do, you need to perform the whatever the inputs you have here. That is the idea we need to do, that if it is 0 0 then what happens, and then 1 1 what happens. The flow we need to do here, we need to derive the inputs for the D here. That is the next step we are going to perform. So what we are going to do now, just you see here, we have one exception here. That means in SR flip-flop you cannot apply 1 1, right? So we would have written it as not applicable in truth table, but here while converting any flip-flop to that means any flip-flop to SR application, That means we are going to use that D flip-flop to SR flip-flop. So what we can do here, instead of not applicable, instead of this not applicable stage, what we can do here, you can just put X here. Just put this as X, this as X. That means it can be anything. Why I am doing this one? Since you can see here we are not going to give 1-1, right? So we know that if it is we are going to use the D flip flop as SR flip flop, we are not going to use that 1-1 case. So I can put here XX. So that is the idea behind putting the X. And now what we need to do now, so we need to derive the expression for 0, 0. That means if present state is 0, and I would have written this as a present state and then next state in my previous slide. So don't confuse yourself here. Whenever I put Qn, that is present state, and whenever I put Qn plus 1, it is the next state. So if it is 0, 0, you can see here, if it is a 0, 0, then the D input should be 0. So this should be 0. If it is 1, 1, then it should be 1. So if it is again 0, 0, it is 0. If it is 1, 0, if it is 1, 0, then it should be 0. If it is a 0, 1, so if it is 0, 1, it should be 1. So if it is 1, 1, it should be 1. So it should be 1. And you see here, in this case, that means it is 0. It is here don't care condition. So if it is don't care condition, you can also have a don't care here. Why don't care? Because I am not going to give 1, 1 input. So at that stage, whatever the output, I don't need to care about the outputs, because SR in SR flip flop, I never give 1, 1. So that is the idea. So we have just derived the conversion table here. So what we need to do now, we are going to put the K map and find the equations, right? So for D input, we need to derive the expression using the Karnaugh map. So I will draw the Karnaugh map and I will show you. So you can see here, we have just drawn the Karnaugh map. So derive the expression for D input using SR and then Qn. So we have seen this one in the previous lecture. Please refer my previous lecture. The steps to derive the expressions, we need to go for the Karnaugh map. That means we need to take this as one input, this as the another one input, and this as the third input, right? Since we have two inputs for the SR flip flop, we need to take this as Qn as the another one input. So this is three inputs now. So yes, and then RQn is here. So now we need to put this one. So we know this one, right? So if you are writing the minterms, this is 0, 1, 2, 3, and then 4, 5, this is 6, and this is 7. So if you are writing this one, you can straight away write the values now. This is 0, this is 1, and then 2 is 0, 3 is 1, not 3 is 1, 3 is also 0, I think. So these four have been completed, and 1, 1, XX. So this is 1, this is 1, this is X, and then this is also X. So this is the mappings we have done for the D input, and whatever the expression we are just deriving from here, that is nothing but it is a D, right? So how will you draw the map with the pairs and then quads? It is very simple. You can see these four are one quad, so I can map this as the quad. So this is quad number 1, and you can see another one is here. So there is no possibility for quad, so that I need to go for a pair. So this is pair number 1. And what is the equation for this one now? For this pair, only I need to write this one. So it is R bar Qn, that is for pair number 1. And for this quad, I need to write straight away it is S, right? So what is the equation we have finally derived for the D input? So this is the D input, that is S plus R bar Qn. So this is the expression we are getting for D input. And what is the next step? We need to draw the diagram, right? So logic diagram need to be done. So I will just go to the next page with the equation. We will try to draw the diagram. So the next step, we need to draw the logic diagram. So I will just draw here. So the next step, it is logic diagram, right? So in logic diagram, so the point is, what is the flip flop you are having with you now? What is the flip-flop you are having? Tell me that. It is a D flip-flop, right? So you have D flip-flop with you. That means one input should be D. That means this input should be D. And you have Qn. That means this is D and this is Qn and this is Qn bar. So this is the flip-flop you are having. And what is the two inputs you are having with you? What is the two inputs you are having with you? What is those two inputs? That is one is S and the other one is R. And that is what we are going to do now. So here what we need, what is the gate you need? You need an OR gate here. So put an OR gate, put an OR gate. So that should be connected to D input. That should be connected to D input. And what is the one input? It is S. So straight away you can give yes. And what is the other one? You need to put a AND gate here. So draw an AND gate. Draw an AND gate. So that should be given to one input of the OR gate. That should be given. And what is the one thing? It is a Qn. So this Qn should be connected as one input. So I will just take from here. So there are two inputs, right? So this input, I will just connect it to Qn. And what is the other one? It is R bar, right? So we need to put a NOT gate here, and we need to connect this one. So now you can see this. This is actually S plus R bar Qn. Right? So this is R bar, this is Qn, and what is this one now? R bar Qn. So now you can easily understand the procedure. So what is the thing we have done here? If you give 0 0, what happens to the Qn? It will be remains in the previous state. No change condition will be there. And if you give 0 1, the output will become 0. If I give 1 0, Qn become 1, and I cannot give 1 1 because it is a SR flip flop. Now you can see that this particular thing is actually an SR flip flop. This is SR flip flop. Just I am giving SR inputs and it will work as an SR flip flop. And so we will continue to the next one. So I will go much faster now because you would have understand all the concepts now. So I am going to do T flip flop using D flip flop now. So now you can see here I have just taken the next one. That means we are going to convert D flip flop into T flip flop. So what are all the contents we need? So first excitation table of the D flip flop that I have taken, and the truth table of not SR flip flop. Actually it is the T flip flop, right? So we need T flip flop. And then the conversion table, what we need to do, we have to take the truth table as it is and we need to derive the inputs for D. So what is the procedure we need to do here? So we have to see this Qn and then Qn plus 1. So for 0 0, what should be the D? So it should be 0. For 1 1, it should be 1. And for 0 to 1, it should be 1. It should be 1. And for 1 to 0, it should be 0 simply. So what is the point here? You can easily direct this one anyhow. So we need to derive the expression for D with the input of T and then Qn. The point I want to explain you can just see this three parts only separately. You just see this one. So this one, this is the input, and this is the another one. And for this I need to draw the Karnaugh map, and you can see this. For 0 0 it is 0, for 0 1 it becomes 1, and for 1 0 it becomes 1, and for 1 1 it is again becomes 0. What is this one? What is this one? So I'm not going to draw the Karnaugh map. I'm not going to do that anyhow. So what I'm going to do now, I'm just directly telling you that this is an XOR gate, right? So you can see, you can relate to the XOR gate. When two inputs are different, then the output becomes 1. So you can simply put here, that means the expression can be directly written here. That means D should be is equal to what? T XR of Qn. T XR of Qn. Why we need to go for the Karnaugh map? No, you don't need to go for the Karnaugh map. We can directly write. That means D can be related to the T flip flop for the two inputs, that T and then Qn. You can XR these two simply to get this D. So what I am going to do now, I am just going to draw the diagrams right away. That means, so this is actually step number D, that means D expression. That, or anything, it may be derive the expression for D, you can write anything maybe. Right, for E, we need to draw the logic diagram. So it is very simple, right? So what is the logic diagram now? So we know that in our hand, we have D flip flop with us now. So D flip flop is with us. So this is a Q and then this is Qn. This is the D input. So simply we know all these kind of things. Already we have seen. This is D and this is Qn. This is a Qn bar and this is actually D flip flop, right? So what is the input you are having? You with us, with you. That means I am going to have a T input, right? So this is actually T. So the point is, what we need to do now? We need to write the expression. That means we need to put an XOR gate. We need to put an XOR gate. So put an XOR gate. So that is the idea. So this should be connected to D. That means one input is T, another one input is Qn bar. That means this is T and this should be now, should come with this. So now you can see, so this is actually T input and this is actually Qn bar. So what you will get now, T XOR of Qn, right? So you have got this one. So what is the point here? So you can just use this as now. So what is this one? This circuit is now, it is a T flip flop, right? So inside that we have D flip flop, but it is working as a T flip flop simply. Right? So this is the conversion. So what is the next one? We need to convert the JK, we need to use the D flip flop as a JK flip flop. That is the next step. So I will just draw the diagram and I will show you. Right. The next one is D flip flop to JK flip flop. That which means we are going to use D flip flop as a JK flip flop. So the point is the procedure is same again. We need to take the excitation of the D flip flop that we have taken here. Truth table of, again I need to change this. Truth table of JK flip flop, right? So we need to take truth table of JK flip flop. So we have taken the truth table of JK flip flop and the conversion table. So what is the conversion table? The conversion table, again we need to take the same truth table. See this one, please try to understand me. In some cases I will tell this as a present state and this as NS, next state. So or I will give notations as Qn and then Qn plus 1. So don't confuse yourself, I have already told you that one. So now we need to derive the expression for D with the Qn and then Qn plus 1. So what we need to do now? So for 0 0, what is the that means excitation table? That means the input for converting from Qn Qn is 0 to Qn plus 1 0, it is 0. So from 1 1 it is 1, and for 0 0 it is 0. 1 0 it is actually 0. You can see here 1 0 it is 0, and then from 0 to 1, from 0 to 1 it has to 1, and from 1 to 1 it will be same. From 0 to 1 you have to put 1. So from 0 to 1 it has to be 1, and from 1 to 0 it has to become 0. So now this is the thing, we have just derived the inputs for D and we need to draw the Karnaugh map now. So it is now the next stage, you need to draw the Karnaugh map, and you can see now I have just taken the taken the K map, and we are going to derive the expression for D using J, K and then Qn. Right? So what we need to do now, we need to just put this value straight away because I have just written the min terms here. So this is a 0, so we need to put 0 here, and 1 for next to 2 it is 0. So this is 0, so this is 1, so this is also 0, and for 4 it is 1, for 5 also it is 1, and for 6 it is 1, and for 7 it is actually 0. So this is the thing we need to put it in the K-map. And what we can do here, it is very simple, very simple. So what we can do here, we need to cover all this one. So there is no quad possibility, which is not possible here because no 4 ones are adjacent to each other. So what we can do further things, we can cover these two ones separately and these two ones separately, because we don't need any overlapping pairs here, since if you take this as one pair and we need to take another pair, this one, and we need to take this pair. So this should be taken as a overlapping pair. And we have seen all these kind of things already. So simply what we can do, you can take this one and this one as one pair and this one as another pair. There is no other go, no other go. So this is the idea. So make it as this is pair number 1 and this is a pair number 2. And what is the equation? We will get it down for D now. So for D, which is equal to, what is the pair number 1? So it is actually straight away we can write this as now K bar Qn plus, what is the next one we have? So these two, so for J it will come, straight away J will come, and we need to see these two terms, and common term is Qn bar. So this is the expression we are getting for D now, and with this D expression we can draw the logic diagram, right? So I will just bring the page. So you can see that this is the expression we have got, and what you have with you, simply you have D flip flop, right? So this is a D flip flop, and this is Qn, this is Qn bar. So this is actually D input, this is Qn, and this is Qn bar. And this is D flip flop, this is D. So D flip flop, this is D flip flop. And what is the inputs you are having with you? 2 inputs you have. So actually J is one input, and then K is the other one input. So I will just write it down. So J is one input and then K is the other one input. So the point is we need to put this plus here. So we need to put an OR gate here. So one OR gate should be drawn. So this, maybe I will move this one further. So this should be one OR gate. So that is going to be the input of the D, right? So this is the input of D, and we have 2 inputs here, right? So one input and then 2 input. And what should be this input now? So this input should be K bar Qn, and then this input should be J Qn bar. So what we need to do now, we need to put a AND gate, we need AND gates, maybe I will draw. So I have just taken 2 AND gates here. So what is the one input now? It should come from Kn bar, right? So what I need to do, I have to put an OR gate and I have to put here this one, and the other one should come from Qn. Qn. So I will go from here. So this should come from Qn. So this is the Qn. So this should be connected to this point. That means we have here K bar and then this is Qn. That is one thing. And what is the other one? What is the other expression? It is J, straight away J. So I can take it from here. And what is the next one? What is the next one? It is Qn bar. So straight away. So no NOT gates are necessary here because you have a Qn bar straight away. So this should be taken from here. So this one, so I have to take to here. So finally we have just drawn the diagram. So what is this one now? So you have to connect this one, right? So this should be connected to this one. And what is the input you have here? It is Q n bar and this is J. So this is actually the diagram. The point is this one now should be taken as this. That means you have to take this one, and then this one. This is Qn, this is Qn bar. And you can see this one. So this is now work as JK flip-flop. You have D flip-flop, but it is working as JK flip-flop. Can you understand the point? Whatever the conversion we are making, just you have JK now. So if you give 0 0, the output will be unchanged. If you give 0 1, it becomes reset, and 1 0, it becomes set. And for J is equal to 1 and then K is equal to 1, it is going to toggle now. So output will toggle. So this is how we need to convert the D flip-flop to other flip-flops, right? So what are the topics we have seen in this class? See, we have just started with the content realization of other flip-flops using D flip-flop. And the procedure we have seen already. What is the procedure? First, we need to write the excitation table of the flip-flop. So whichever the flip-flop you have, and the truth table of the flip-flop, whichever you need to convert, and then the conversion table. So the conversion table has to take the truth table of the flip-flop we need to convert, and we need to derive the expression for the flip-flop whichever we have. So we have just drawn this one. You can see here we have just taken the conversion table and we have drawn the logic diagrams with the expressions of the K-maps, right? So we have just converted this one, and we have seen how to convert the D flip-flop to T flip-flop. So you can see here, this is the diagram of T flip-flop using D flip-flop, and also we have taken the final one. We have converted the D flip-flop into JK flip-flop, and you can see the logic diagram. This is the final logic diagram we have taken the JK flip-flop. Thank you. We will see in the next class.